Welcome to section 2.6, Logical Equivalence. So today we will work on proving that two statements are logically equivalent. We'll also write the contrapositive of statements, and we'll memorize and internalize De Morgan's laws. So just as an introductory note, the activities we did for section 2.5 and 2.6 showed that there may be different statements with the same truth tables. So what we're doing today addresses this case. Definition: two statements are logically equivalent if their truth tables match up exactly. That's going to make it easy to prove. If we want to show that two statements are logically equivalent, we'll just build their truth tables and compare the columns. So here, show that if P then Q is logically equivalent to if not Q, then not P. So I managed to build both truth tables in the same table, so we will be able to compare the columns in the same table. So firstly, we write the truth table for P and for Q. Easy: true, true, false, false, true, false, true, false. And then we're going to go straight to this one, if P then Q, and we know it by heart: true, false, true, true. So the bulk of the work is going to be to write the truth table for this statement there. First we need to write not Q as well as not P, and lastly, if not Q, then not P. So not Q, we just flip the truth values of Q, so true, false becomes false, true. And for not P, true, true, false, false becomes false, false, true, true. Now when we have an implication, we remember that the implication is false in the case that we go from a truth statement to a false statement. So false to false is true to false is false to true is true to true is true. Conclusion: the truth table for if not Q then not P is true, false, true, true, and we can compare this column here to the column if P then Q here and realize that it's exactly the same, and therefore we can conclude that these two statements are logically equivalent. In fact, if not Q then not P is called the contrapositive of if P then Q, and we will discuss it extensively in chapter 5. When two statements are logically equivalent, then we can combine them using a biconditional statement. So here's the example: if P then Q, if and only if not Q then not P. So lastly, we mentioned that we would talk about De Morgan's laws. We'll focus on them in activities, but here are the laws. They are very important, and we'll have to internalize them and get very comfortable with them. So not P and Q is logically equivalent to not P or not Q. And not P or Q is logically equivalent to not P and not Q. So there's kind of an interesting thing happening here. We sort of distribute the not, but at the same time the conjunction becomes a disjunction, or the disjunction becomes a conjunction. Alright, that's it for today. Thank you.